Welcome back. Welcome back. Today we have a nice set of lectures for you, and you may have noticed a little bit of filming equipment in the back in our continuing effort to provide more value add to your university experience. We're filming this both for your benefit and for the benefit of others, and so this will be available for replay later, and for those who for whatever reason have a conflict or have an issue today. So let me quickly let you know where we're going today. Today we're going to return your homework finally. We're going to get your homework back. We're going to go over that solution. We'll discuss the topics of today's lecture. We'll have our little coffee break fairly quickly. The first part will go fairly quickly. Then we have a middle chunk of lecture where we'll lecture on some theoretical and conceptual ideas in capacity measurement and railway lines. Then another coffee break. And then we'll have a more detailed focus on the International Union of Railways 406 capacity calculation method, and that will be more of a kind of an exercise activity for the last part of the day. So I want to hand this off to Fabrizio. He's going to present the homework solution for you.
Yep. We spread out both the handout of the slides and written paper, which is something that we expected you to present. Like the thing that we spread out was what we wanted really you to give us. So it's just to give you an example of how a handout should be written, or what we expected it to look like. I got some of the most common mistakes that were quite much always the same. So now we are going through the explanation. Okay, good job. So I guess you already know the assignment. We had the demand. One of the most common mistake was not a methodological mistake, but was just to misunderstanding this concept of segments and lines. What we meant for being segments were the space between the stations, while these are the lines where we are given the demand. It doesn't mean that we have 3 lines of trains that are running, one between A and C, one between B and D, and one between B and E. That was just a way to represent our demand. That could be, usually the demand in transportation is given between an origin and a destination. That's how it's represented. So in example, we have should be 300 people going from A to C, and some other bunch of people going from B to E, and etc. That's just a way to represent the demand. So these were the demand, not the train lines. That was something that somebody got confused on. So this is something that we got from somebody of you. We saw this in some of the of your handout, and it was quite a really good way to represent all the data that we have and all the data that we calculated, just in a general overview that comprehends everything. So we really appreciated it so much that we wanted to show everybody how it looked like. So in just one scheme, we have the demand, the total demand. So if we go back here, we just summoned all of these lines demand on lines. So it was 300. This is the busiest segment, and etc. Then we have the line. That's quite easy. We summarize here the distance, the speed, and then the calculated time. We didn't put the time at the station because it depended from which service we were designing. But this was 7 minutes for just running up just reversing the trains that comprehended 1 minute of boarding and 1 minute every stop. First of all, before continuing, I wanted to point out something that is not a mistake, but is something that you really should think about. That is the representation of unit of measure. In every equation, you're supposed to be engineers, or somebody is not an engineer, but in any case, every equation needs all the units of measurement. Every data, you can't just say this is 3. This is 3 trains per hour. This is 3 train sets. It doesn't make any sense to say just 3, 4, 500. And it's a really, really good way to check whether your equation is set up in a fine way. So if you check whether the hours can be cancelled by hours in another fraction, or if trains goes out with other trains, and etc., then you can really know, you can really check easily and really quick whether you're summing up hours with kilometers, and then maybe there's something that is not really going good in the equation. So everybody, that's a mistake that almost everybody, I think just 1 or 2 didn't miss any of the measurements. And it's really useful to you and for who is in charge of correcting and marking the hands out. So we start from the frequency needed. That's a quite easy way to calculate. We have a demand. We wanted to know, the first assumption is that we are running just one service from A to E, back and forth. This is the simplest way we can run the service. So we have to fulfill the demand that is in this segment. There is 1,000 passengers per hour. This is 1,000 passengers per hour. We are assuming that we just have one train set per train. And we want to know how many times we have to run one train set every hour. So this is another point of confusion that somebody of you had. Somebody of you mismatched trains and trains per hour. So in this calculation, we had somebody thinking that we were calculating how many train sets we were having for every train. And maybe this is due to the fact that usually everybody calls trains both the rolling stocks and the service. So a tip that I can give you is just to make it easy to you. So what I do usually is to call the rolling stock, the hardware, the train set. So we really refer to what is moving. And trains is the service. So we are running one train per hour. That means one service per hour. And we are using 2 train sets per that service. That means that we are using 2 coupled trains, 2 coupled rolling stock to run that train. So if you always use the words train set or trains and you really keep them divided, it helps you not to mismatch them. So we have 1,000 passengers per hour to be fulfilled with 300 passengers per train. Again, here you see we are using all the units of measurement for all the values. So it easily comes to be trains per hour because passengers and passenger is cancelled. And we go to the result. There is 4 trains per hour. That means 15 minutes between every departure. If we just have 300 passengers per train, or in case we are using the long formation, it means 30 minutes. Is there anybody that doesn't have this passage clear? OK. This is the first part for all the rest of the exercise. Then we need to calculate the rolling stock needed to run this service. If we are having, in the short formation case, 4 trains running every hour. But how long does it take for a train to go back and forth from one point to the other? Here is another point where many people had mistakes. The calculation of time and or the distance that the trains are covering. If we have a bunch of stations here, and we are running the round trip time, the round trip time is called it round trip because it's a round. So we are going from here to here, then we are having a stop here, then we are reversing the train, and here is again the same path. And this was a source of mistake for many of you, and in first instance, it was a source of mistake also for me. So yeah, it's quite tricky. It's a really easy mistake to make, but then, of course, from this value, you have all the following values mistaken, and it's knock-on mistakes all over the homework. So we have twice the distance to be covered, twice the stops, and twice the reversing time at station. So that's why we are doubling everything, and then we are just summing up all the components. So this is the first reversal of the train, the first time for A to B, first stop, B to C, second stop, C to D, stop in D, and then the time to get to E. Then we are getting back. We are having, again, 7 minutes of reversing the train and 28 minutes, and we are just going back. It took 2 hours and a half, more than 2.5 hours for the train to get back. So what does it mean? We need, for little slow, we need 4 trains per hour multiplied by 2.6 hours, 10.4 train sets, 11 train sets. Of course, we are running up because we can't have 10.4 train sets. We can't run just half a train. If we go back to here, there is something that we didn't really consider a mistake, but we are having what you can see here, we rounded up 3.3 trains per hour to 4 trains per hour. It's right not to round it up because you're fulfilling the demand also with this number. But the reason why we round it up is because usually you have a cyclic timetable. There is usually hourly based, half an hour based. That means that you're not running 3.3 trains per hour. That could make sense, but you're running 4 trains an hour. In an example, the S trains usually runs every 10 minutes. That means 6 times an hour. It's not every 58 minutes. Otherwise, you would have it runs at minute 10. Then in the next hour, it's running at minute 8, and then the next hour it's running at minute 6. It doesn't really catch passengers' mind this way. And of course, if it's cyclic with 1 hour, it's much easier to handle. So this is not a mistake, but it's something that next time you should do. Then the service design. So we are in the calculation of the cost. This is an input. Fortunately, from here to then, the mistakes from here after, the mistakes made here were not spread out. So we can start again if we had some mistakes. And we have 3 trains per hour because we have 1 train every 20 minutes. We calculate again the number of train sets that we need to run this service every 20 minutes. And we are calculating the cost for tracks, crew, and the rent. Let's go to the first component. There is the track. How many kilometers are we running every hour? We are running all the path. So A, B, C, E, E. This is how many times per hour are we running this service? What? Trains or train sets? No, it's train. Yeah, because we are having, if this is time, we are running the service 3 times an hour, meaning it both ways. So every hour, this train will go back and forth from here. But there will also be another train that maybe starts here and go back from here. And there's another train that maybe is on this part that is running here. That's why we are multiplying it for 3 times, because we are having 3 trains per hour. Then the other ones are quite easier, because we have the crew that is depending on the train set. Every train set needs a crew, and every train set is going to be rented. So how many train sets are we running simultaneously at the same time? Is it the train sets or the services? We are running 1 service every 30 minutes, 3 services an hour. But to do this, to make this service, we need 8 train sets to be run simultaneously. That means that we need 8 times the crew, 8 crews, and to run 8 trains. That's why the track is multiplied by the number of services we have in an hour, and the crew and the rent is multiplied by the number of rolling stock that we have. And this was over 20,000 kronas per hour. Okay, we have this is the question D, the question 3 about the time that a train is spending at the out of service. How did we get to this 4 minutes? We have 1 train that takes 156 minutes to go back and forth from the first station and then back to the first station. But when is the next time that it has to leave? How many train sets do we have? It's 8 train sets, so it means that every 8 departures, it is the same train set that is starting. So yeah, let's make it here. The first train is starting, and it comes here, and then go back here. Then we need some colors here. Then is the second train that is making the same. Then we have another train. Well, this is not a good proportion maybe, but we are gonna have 8 trains that are leaving. Every color is a train set, a rolling stock. So after 8 of these, the same train is leaving. But we say that this, is gonna take 156 minutes. And the next departure of this train is gonna be in 160 minutes. There is exactly the frequency, the interval between 2 departures, that is 20 minutes, multiplied by the number of rolling stocks that we have. So this train is going to be 160 minus 156 minutes at the stop.
This is for the next service to begin.
Exactly.
But
Not for the next service that
The same piece of equipment.
yeah. But the question was like the train. How much time does a train spend? So
we have 8 trains.
can you like 4 minutes divided by 8 and
That's something that somebody did, but why should
should be like more concentrated on service or not? How?
the question is, how much time does the train I can.
Out of service waiting for the.
So in that case, we meant the train set. But it makes sense. It didn't need to be explained actually, because yeah, a train service is not waiting. So yeah, the train set is going back in 156 minutes, and the next service that train set is going to run is in 4 minutes after it come back. Is it clear to everybody? So let's move to the next one. Okay, this is the economic part. We wanted to sum up the operation ratio. There is the cost divided by the revenue. So we wanted to know what is the revenue needed to equal the cost. It was implicit in the question, but usually, or actually always, the revenue is and the cost are referred to the passenger per kilometer. That is not passenger per kilometer, but it's passenger multiplied by kilometers. There is the sum of all the paths that all the passengers are having on that train or on that service. So if 2 people are running for 1 kilometer on 1 kilometer on a bus, is the same amount of passenger kilometer of 1 person running for 2 kilometers. That's a measure of how much you are producing. So how much service you are producing. So that's what we refer to the cost and the revenue. So we wanted to divide the cost, because it has to equal the revenue, for the passenger kilometers in total. And what is the amount of passenger kilometers that we have? As I just said, it is the sum of all the paths that all the passengers are having on that train. So we have the demand. We had the here we can either multiply the 300 people for the distance between A, B, and etc., or we could also multiply this amount for this distance and sum up this. It's exactly the same. So as you find it more comfortable, but it's anyway 38,000 passenger kilometers every hour. So what we are having is that we compare the revenue every hour with the cost every hour. So passenger kilometer is, again, here many people of you just forgot to multiply the distance for 2, because in the assignment it was said that the demand is 300 passengers per hour each direction. So that means that you have to sum it up again when the train is coming back. So these are all the segments. This is how I would do it, but many of you just multiplied the lines for their distance, and it's fair enough again. So if we divide the cost that we have from this question by 38,000, we got the cost that we have that should be equal to the price that we are giving to the passenger. There is half a kroner circa per passenger kilometer. And the following question was exactly the same. We just wanted to know what is the revenue that we want to get the half of a value of 0.5 of the fare box recovery. So the fare box recovery is just the opposite of the operation ratio. So it's the revenue divided by the cost. So it just comes by the equations, and it's exactly the same procedure that we applied in the previous demand. Finally, we got the fourth question. That was the one in which you had the most freedom to build up your services. It was quite guided, because it was quite easy to set the services 1A to E, and it was what it was said, and one service B to D. So we just applied again the same procedure that we just applied here, just with a bit more freedom, just to understand if you were able to do it yourself or there was some guidance needed yet. So we calculated first the capacity needed, so the number of trains of services passing every hour. Then the train services, the train sets needed to run that service. So it was 2.5 train set. That is again run 2-3 train sets. And we applied again the same cost calculation that we applied in this equation. So again, the track charge was multiplied by the number of services that we are running. That was somebody of you, that is a strange mistake, not a mistake, it's just distraction. Somebody of you took one train running from B to B, that is fine, but didn't count that we are already fulfilling that demand in the calculation of the service A to B. So if we are having, I put the trains here because yeah, you get the amount of demand that we are fulfilling. If we are running a train of 500 people with capacity of 500 seats here, of course, what we have still to fulfill is not again 1,000 people, but is the remaining part, that is 500, and here is 200. So that means that we can run a train a service between B and D with just 500 people capacity, and then the rest is going to be run by another train set that is running 1 hour, 1 time per hour with 500 capacity. So I think it's just distraction. You just didn't take out the part that was already fulfilled. And that's it. Let me just check whether we have. Some tip that I think is useful to you. You should always give some explanation of the calculation that you are giving, because it's so easy just to say A plus B is C, but then if any mistake comes out, it's so hard to understand whether you already understood it or it's just a numerical error. And this is for the academic part, but let's just imagine this is a calculation that some company asked you to do. So you have to present it. And of course, people that you are presenting your calculation to is not necessarily somebody that understands what you are doing. If they understood what you were doing, maybe you were not needed to them. So always try to make it clear what you're doing, and at the same time, don't write too much. There was some case in which somebody of you write, okay, literally, okay, now I am calculating this. Okay, of course it's clear, but it's maybe too much. Imagine just a manager that is writing this paper and it's taking half an hour just reading words. That's nice, but maybe there is something else to use your time for. So yeah, always keep the balance between explaining everything you're doing in a concise way. And never just do the calculation, because everybody's just able to do the calculation. And it's also useful to you, because imagine yourself next year, maybe you want to revise this course or any other course, you just see some calculation, and of course you can't remember what you did. So it's useful also to you just to have a bunch of words that explain what you're doing and why you're doing that. And maybe, in some cases, the hypothesis that you're assuming. And of course, keep it tidy. And maybe a good suggestion is to highlight the results. Because, of course, if imagine, again, a manager that is just taking the paper, and what is really concentrated on is the result. That's the first thing that you are looking at. Then is looking at the description. So the results should always be visible at the first eye blink. And that's it. I hope everybody of you got the handout that I prepared, just as a hint of what it could look like.
I have difficult to understand the question, so it was very difficult for me to. What's the what the teacher wants me to solve.
Then you are more than welcome to ask again us. What do you mean? If you have any doubt, there's no reason just to try. Yeah.
I was late in
Okay. Next time, maybe it could be a suggestion to yourself to be a bit earlier. So.
because I talked with other students, they said maybe like this. No, I think like that. Then I called other students. So it was.
Of course, in any text, again, not only in the academic field, but you can always have something that is not really clear. Maybe we think that it's clear, but it doesn't mean that it is. So if it's not clear, just ask.
But
Then we can.
I calculate everything backwards for the way you. I calculate the loop first, and after the.
Yeah, I mean, if you're going on what you think it is, then you're not sure that you're doing what you are expected to do. So you have some percentage of probability to get it right and some not to get it right. So it's just worthy to ask and to be sure that what you understood is fine. And of course, we always try to make it the clearest possible, but we are human, so. And what is clear to me, maybe is not clear to you, and vice versa. So it's just skill. And my native language is not English. It's not yours either. So, and we are communicating in English. So this is another difficulty. So always, it's not a pity. It's not a sin.
I get 4 in this calculation, 4 minutes. But I thought that is okay. How much should the first train wait for another train to departure? I understood it in this way.
Oh.
So the first train departures, then wait for a half, because there's 8 trains. So
But
first departure, wait a half
in this case, this is 20 minutes, because you already calculate. This is the interval between two departures. So you already calculated, and you need it for all the other calculations. So it's this was not the purpose of that question. And of course, you can try to.
Yeah, but I can show you.
Yeah, so if the train waits for 20 minutes and 30 seconds, they fulfill that 160.
Can you repeat it, please?
But, it's okay. I got this point.
Yeah.
Okay. We're done with
Fabrizio, thank you so much. So I think to jump off on what Eric was saying, and again, there's a lot of assumption, not just because we're communicating in English, but because we're communicating in the language of a specific trade. So if we were teaching you plumbing, there would be certain kinds of assumptions about the language that would mean certain things, like I want you to sweat a pipe. And if you were a plumber, you'd know what that means, but you're not plumbers and you have no idea what I'm talking about. But lots of different language comes into play in different fields. And so you're not alone just because you're a non-native English speaker. That's not the only issue here. When I'm teaching topics in similar things in operations research to native English speakers, there's still a language barrier because there are certain kinds of assumed technical understandings of the way things are phrased that are just built up over time that take a little bit of time of practice to get used to. Even for a native English speaker, there's just certain modes of thinking and certain kind of assumptions that we just assume things are going to be a certain way. So in the timing of the train, Eric said, hey, 20 minutes, 30 seconds, done deal. But that then violates our presumption that we want the repeating schedule every hour. Because 20 minutes, 30 seconds means the trains start to offset in the second hour, and then they keep continuing to offset, and we end up in a kind of a cakewalk where suddenly everybody's in the wrong chair at the end of the music playing. And so we want the trains to be in a repeating cycle. And that's just kind of an assumed thing. It's just one of these trade secrets. We just are all thinking that way. Now, if we deviated from that, we would probably be more likely to specifically say, hey, we're going to deviate from that. Or we're not going to choose 1 hour as our standard cycle of time. And we might specifically say that. It's just so common. Certain things are just so commonly expected that they go unstated. and they go undescribed. But I wanted to say thank you so much. I think Fabrizio and I both want to say thank you for those of you who really, we could tell you put a lot of effort into your work. And even if you're a little annoyed that maybe we marked too many wrong or we gave you too many error comments or something like that, we notice when you're working hard. We do notice that. We notice the cleanliness of the presentation. We notice when you've really made an effort to make things organized and clean. And we've tried to emphasize that when we were marking the score on excellent for legibility. We're really saying, hey, we really appreciate the time you're taking. We really appreciate the time that you are taking to make your work legible and to make your work presentable, and we notice that, and that means a lot to us. I wanted to have a short discussion before the longer discussion, and what do you think about this schedule right here? This minimum cost schedule. What do you think about that? Does that solve anybody's problem?
It's cheap.
It's cheap?
Yeah, cheap.
Is it really cheap? Is it really going to be cheap? What's going to happen with that schedule? This happens a lot, I think, especially sometimes here, but I think especially also in North America, where maybe public transit is viewed as a product and not as a community service. Yes, Minguaras.
Like if we have capacity of 1,000 passengers and the train is 100 passengers, it means like there's no even one place left like as a free.
Certainly, we have no variance. We have no support for variation. But I think the thing I really wanted to focus on was the time cycle. And this presumes that people are all going to reevaluate their time in their life and all get on that 1 time an hour train. And I think certainly from a passenger service perspective, you know eventually people are going to say, this isn't working for me. And you're going to see a fall off. So this is going to have a cyclical effect, a feedback effect. You do this, you're going to change the passenger demand curve. Passenger demand is going to drop off. And then suddenly, this is going to cost more again. So this is a problem. And this short-sighted accounting where, well, you know, we don't really need to run so much service because we don't really have a demand for all that service. And so we're going to cut back and degrade the service. And then you degrade the service, and then your demand falls back even further. And then before you know it, you don't have a service. And this is not unique to transportation. You can do a similar accounting argument in a lot of other manufacturing and economic firms where you have to be careful about assumptions about marginal cost, marginal revenue, and how you go about doing the accounting for how you do cost cutting in a business. And I've seen that frequently. So again, I appreciate the time you've taken to make these clean and legible. We really noticed that, and we're keeping track of that. We've kept copies of all your assignments for our records for the final at the end of the semester. So we'll be looking at all of this in total when we evaluate your performance at the end of the semester. So discussion question today. Discussion question. I'm going to leave you with this, and we'll have our coffee break and come back, and I want to ask you about this. What is capacity? What is capacity? Think about that. Talk about it yourselves. Let's take a 10-minute